All right, so let's talk about some more rules using this power rule. So again, this d over dx means I'm going to take the derivative, right? I'm going to take the derivative with respect to x, and I've got this constant here in front of a function. So what this says is I can move the constant on the outside and then just take the derivative of the function. So you basically carry along the constant to take the derivative. So taking the derivative of 4x cubed, you can carry along the 4 and then take the derivative of x cubed, which is 3x squared. So I bet you'll be able to go right from here to here many times. Okay, this one seems really easy, but it's hard to remember to do. So derivative of e to the x. Remember, our power rule is the derivative of x to the n. So the n is a number up here, right? And the x is the base. Here, as the number is the base, so it's different. So the derivative of 6e to the x would just be 6e to the x. And if I have functions separated by addition and subtraction, I just go and take the derivative of each of them separately and just carry along the addition and subtraction. All right, so let's look at this one here. So if I want to take the derivative of all of this, just go term by term, carry along the 3, take the derivative of x to the 4th, which is 4x cubed. The derivative of e to the x is e to the x, and carry the negative 2. The derivative of x, remember, this is 1. You bring it down, you get x to the 0. So 1 times x to the 0 gives me 1. And the derivative of this constant gives me 0, right? Always using the derivative of a constant is 0. So the derivative of negative 3 is 0, so it's gone. So there's our derivative. All right, so must rewrite this because I have to have the derivative of x to a power in order to take the derivative. So I've got to rewrite this first. I don't have a rule for division. So I'm going to say this is x squared over x plus 3x over x minus pi over x. Just going to go really slow here. So the function is x plus 3 minus pi x to the negative 1. I'm just going to write it like this so that I'm ready to take the derivative in the next step. So I'm writing this one as the exponent that it is. All right, so now f prime of x, to take the derivative of x is 1. The derivative of a constant is 0, so I'm not going to write anything. Now to take the derivative here, I'm going to bring the negative 1 down in front, multiply it times the negative pi, so that gives me a positive pi x to the negative 2. So that's our answer. And if you wanted to, sometimes people like to write it without negative exponents. So there we go. So be careful. What I don't want to see you doing is saying, okay, here's my f of x, which is x plus 3 minus pi x to the negative 1. And then some people just think, oh, I know, I'll just take the derivative, and that's equal to 1 plus pi x to the negative 2. So this is wrong because this is the function, this is the derivative. The function does not equal the derivative. So be really careful. Notice what I did here. F of x equals, oh, f prime of x equals. So be careful with your notation. You're going to need to know which is your derivative and which is your function. Okay, so this one says find the second derivative. So you're going to take the derivative of the derivative. So first I'm going to rewrite this. So I'm going to say y is, and it's all t's, right? So this will be plus 2t to the negative 1/3 power and plus e cubed. Okay, so y prime is another way of saying the derivative. So if this was written as f of x, just want you to get comfortable with the notation. We're going to have lots of different ways to say the derivative. Okay, so the derivative of e to the t is e to the t. Next term, derivative of t to the e. E is a number, right? So to take the derivative of t to the n will be nt to the n minus 1. So I'll bring the number down and I'll subtract 1. And you just leave it like that. I don't want a decimal up there. All right, moving to the next term. So I'm going to bring this negative 1/3 down in the front. So I get negative 2/3 t to the, now I'm subtracting 1, so I get negative 4/3. And then be careful to take the derivative of e cubed. Whoops, I'm in t land here, right? Derivative with respect to t. This is a constant, right? The derivative of a constant is 0. So the derivative of e cubed is 0. Okay, so this is one derivative. So they wanted me to find the second derivative. So we write the double prime. So I just go and take the derivative of this. So the derivative of e to the t is e to the t. The derivative here, I'd carry that e along. I'd bring this e minus 1 exponent down, t to the e minus 2, right? So this would be this derivative. And then moving on to the last term here, bring this negative 4/3 down in front. So I get plus 8/9 t, and now I need to subtract 1, so I'd get negative 7/3.